students, today we are going to discuss heating effect of electric current. Let us see what is that effect. Here you can see the phenomenon of production of heat in a resistor by the flow of an electric current through it is called heating effect of electric current. We can call this by using another name, that is Joule heating, that is named after the scientist James Prescott Joule. For explaining this heating effect of electric current, we have to consider a purely resistive circuit. Purely resistive circuit means you have to think some resistors are connected to battery or a cell there. Then you know what will happen there. Due to the chemical reactions happening in the battery, it can maintain the potential difference in the circuit and the current can flow through that circuit. Then you know this battery is a source of electrical energy. For maintaining current in that circuit, this battery has to keep expending its energy. Then where does this energy go? Let us see. A part of the source energy in maintaining the current may be consumed into useful work. For example, we are giving electric energy. That time what will happen to the electric fan? That will start working. You can see the blades of the fan. They are rotating there. We are providing electric energy. There you can see mechanical energy. Electric energy converted into mechanical energy there. Like that, another example, electric mixer. So we can say battery is providing that energy there, that we are getting in the form of this mechanical energy. So we can say part of the source energy which is maintaining current in the circuit, that is consumed as that work there. Okay, then rest of the source energy may be expended in the form of heat energy. If you are using electric mixer, after some time if you are touching that, you can feel warm there. What is the reason? That time this energy is converted into heat energy also. So the rest of the source energy may be expended, that is getting dissipated in the form of heat energy. Then what will happen? It will raise the temperature of that gadget, and if you are touching that, you can feel that as warm. Based on the heating effect of electric current, we can learn one law, that is Joule's law of heating. From this you can know about how much amount of heat is produced in a conductor or a resistor, we can say. So here the amount of heat H produced in a conductor is directly proportional to the square of the current I passing through it, its resistance R, and the time t for which the current is passed. So here from the first statement we get the heat H produced is directly proportional to square of the current. You can write that as H is proportional to square of the current, like that way, proportional to its resistance. H is proportional to R. Then the amount of heat is directly proportional to the time t for which the current is passed through that circuit. Now we have to combine these three. Then we can write H is proportional to I square RT. For writing this as an equation, we have to remove this proportionality sign. How to remove, you know, there we have to write one constant. Here I am using k into I square RT. Then for writing this equation, we can put this k as 1. Then you will get H is equal to I square RT. This equation gives us the amount of heat produced in that conductor. H is equal to I square RT. This amount of heat is directly proportional to square of the current, resistance, and the time. What is the unit of this heat energy? That is Joule. You know that unit. Now we have to derive the equation H is equal to I square RT. From that Joule's law of heating, Joule's law, we wrote H is equal to I square RT. Now we are going to derive this equation. So here you can see a circuit diagram. In this battery there, key, ammeter, voltmeter and a resistor. Here we can take this resistor has resistance R and that is connected between the points X and Y. You can see a voltmeter that is connected across this X and Y. We can take that V as the potential difference. Here you can see current is passing through this circuit and we can take that I as current. R is the resistance and we have to consider Q is the charge flowing through this circuit. Then you know children what is potential difference, that is the work done to move a unit charge from one point to another point. From that we can write an equation as W is equal to, W means work done, that is equal to Q into V. Work done is the product of charge and the potential difference. Then you know children Q is equal to I into T. Current is the rate of flow of charge. I is equal to Q by T. From that we can write Q is equal to I into T. Then we can write this as IT into V. This you can write as V into I into T. So here this is work done. No, you know work energy theorem. From that we can write this as energy. But in this case you are considering the heat energy. So you can write as H is equal to V into I into T. Then by Ohm's law we can write V is equal to I into R. Then substitute this V is equal to I into R in this equation. H is equal to VIT. Then you will get H is equal to I R into I into T. So from this you can write I squared RT. So here we are getting this equation as H is equal to I square RT. Children, that's why there I put K is equal to 1. Listen here, H is equal to VIT you know. Then if you are substituting V is equal to IR, you will get that H as I square RT. So here in this equation you can see the amount of heat energy in terms of potential difference, current and time. Here you can see that equation in terms of current, resistance and time. Then if you are substituting here for this I, substituting V by R, you will get this equation as H is equal to V into, instead of I you have to write V by R into T. Then you will get V square divided by R into T. So here this equation for heat energy in terms of potential difference, resistance and time. Let us see some applications of this heating effect of electric current. Some household heating appliances, their example room heater, geyser, electric iron, electric kettle, many are there. In all these appliances we are using this heating effect of electric current. When current is passing through that, it can be transformed into heat energy and that we can use. In all these appliances we are using some heating elements. For this heating element, its melting point is high and its resistivity also high. Due to these properties only we can use this as heating element. Nichrome we are using there. Then another one application, incandescent electric bulb, our bulb. There we are getting light energy there and heat energy also there. Then how can we get that light energy there? If current is passing through that, you can see the filament in that bulb is glowing there. How that is glowing? Due to the resistivity, high resistivity of that and due to high melting point, the filament will glow. Electric fuse, this is a safety device that we are using to protect our electrical appliances if a huge amount of current is passing through that. This fuse wire has high resistivity and low melting point. This is made up of an alloy of tin and lead. Then how to connect this? We have to connect this fuse wire in series with the live wire of the circuit. When the current exceeds, for that a safety limit there. If this current is exceeding that safety limit, what will happen means the fuse wire get heated and that will melt. You know, for this fuse wire its melting point is low. Due to that it will melt and break the circuit. Like that way we can protect our electrical appliances. Next class we will discuss electric power.